Alrighty there. We are going to learn about this learning target. We're going to learn how to factor trinomials of the form x squared plus bx plus c. So b and c are both numbers. So it's going to be in that form. We're going to factor them. And it seems weird to factor that. It may seem weird at first, but it is going to come in handy soon enough as to why we're going to factor these. But last time we just factored like a monomial out of a trinomial. We can't do that in this case because um, we have we just have the x squared in front. There's no number with it, and then the other two have numbers with them. But we can't factor the same thing, like one thing out of each term. So we're gonna do this a special way. It's gonna be kind of like doing FOIL backwards. All right. So remember how we're doing this form. Remember how to do the FOIL method where we have two binomials multiplied together, and then we do the FOIL method, and we get to and we get to this form. A lot of times we'll get to the x squared plus bx plus c form. Well, we're going to start with this form, and then we're going to go backwards to have two binomials. All right. So here's what we're going to do. Here's our procedure that we're going to use. Seems long. If you don't want to write it down, all of it, you don't have to. This is the words version, but we're going to go through some examples after that. This would be a smart thing to put in your notes, though. So put the terms in descending order if they're not already in descending order. That's step one. Step two would be factor out the greatest common factor if there is one. In this case, there's probably not going to be one just um, um, because of if we're saying it's in the form x squared plus bx plus c. So this one we really don't need for this lesson. We'll need it for the next one. Step three would be multiply the coefficients of the first and third terms together. So whatever a times b, in this case, a is always going to be 1 if we're doing it in this form, and then whatever the c value is. What I mean by a is that's what it would be in the very front. Since there is no a value, it's going to be 1. All right, now we're going to find target numbers. Target numbers is something that's new to you. So target numbers are, this will be a vocabulary word as well, two numbers that multiply to give you the product of A and C, and add to give you the coefficient of the middle term, or B. So we're going to use those two target numbers in just a second. So then once we find the target numbers, we're going to set up our parentheses to be in this form, our binomials, x plus something times x plus something. The first term in each parentheses will be multiplied together to give you the f part of the FOIL. Both will be x in this case. So this one we don't really need. And step 7, the target numbers will be added after the x. So our two target numbers are going to go here and here inside the parentheses. And then once you're done, if you FOIL it back out, it should get you back to the the trinomial that you started with. So I know there's a lot, and we kind of took out step 2 and step 6 because they're not going to affect us in this case. But let's go through an example together. So let's say you have the example x squared plus 7x plus 12. Well, it's already in descending order. There's nothing we can factor out, so we're already down to step 3. Um, and step 3 told us to multiply the coefficient of the first and the third numbers together. So it's going to be 1 times the c value. Our c value is 12, so 1 times c is 12. So multiply is equal 12 and adds to equal 7. So that's what I have right here. We want something that multiplies to equal 12 and adds to equal 7. That's what we're looking for. Those are going to be our target numbers. All right? So here's our options. We could do 1 times 12, but that's not going to work because that doesn't add to equal 7, so we're crossing that out. Negative 1 times negative 12 also multiplies to equal 12, but not going to work, doesn't add to it. 2 times 6 adds to 8, not good enough. Negative 2 times negative 6 adds to negative 8, not good enough again. What else? So 4 and 3 multiply to equal 12, or negative 4, negative 3. Negatives aren't going to work, so this is the 1. Our target numbers are 4 and 3. And so remember, then we go to set up our parentheses, x plus something times x plus something, and we put our target numbers in there, 4 and 3. So now we're done. We have our two binomials, and we have the correct, those are the two factors. X plus 4 and x plus 3 are our two factors to get to that trinomial. And our last step is to check them. So I'm going to kind of do this mentally, but if we do FOIL method, the first would get us x squared, which is what we're supposed to start with, right? We have x squared in the front there. Then we do the outsides would be 3x, and the insides would be 4x. That makes 7x, which is right there. And then last would be 4 times 3, which is 12, and that gets us right there. So that takes us back to what we started to factor. All right? So I'm going to do one more example here, and then I'm going to give you some to do, I think one more here. So we have a squared plus negative 9a plus negative 36. So again, we want to multiply to equal negative 36 and add to equal negative 9 because we have a 1 here. So we multiply to equal 1 times negative 36, so that's negative 36, and add to equal negative 9. So we can do negative 36 and 1 or 36 and negative 1. But neither of those add up to the right amount. You have to add up to negative 9. Negative 2 times 18 or 2 times negative 18 would both get to negative 36, but neither of them add up to negative 9. Let's see what else. We have 9 and 4. Actually, I forgot about negative 3 and 12, or 3 and negative 12. There are other ones, 4 and negative 9, negative 4 and 9, and that was it then. The one that we're looking for, though, here is 3. I apologize for using x. Should be a dot or a parentheses, but 3 and negative 9 multiply to equal negative 36 and add to equal negative 9. Sorry, 3 and negative 12. And so those are our target numbers. So 3 and 12 are our target numbers. And then when you set up your parentheses, we do x plus, sorry, 3 and negative 12. X plus 3 is going to be one of them, and x plus negative 12 is going to be the other one, or x minus 12 if you prefer it that way. So let's double check to make sure we're correct. Oh, sorry, it's not x. We have a as our variable for this one, so I made a mistake there. But there we go. That's how you factor it. It's a lot easier than it looks, but just finding those target numbers, it's an interesting method here. All right, so why don't you try it? I have two of them for you. You can do one at a time. The first one says find the factored form of r squared plus 11r plus 24. And the second one has a negative in there, n squared plus 9n minus 36. So why don't you pause it right now, and then you can work them out on your own and double check with me. Remember, use those steps. Find the target numbers, put them into the parentheses, and then check to make sure it works out. All right, so for the first one, remember we want it to be multiplied to equal 24 and add to equal 11. So the two target numbers that I found to work for that would be 8 and 3. So then I put it into the two binomials, and we get r plus 8 times r plus 3. And again, to check that, you can FOIL it. You can go backwards. It would be r squared, and we have 8r and 3r would be our outsides and our insides. And then the last would be 24, and that gets us to 11r plus 24. R squared plus 11r plus 24. So it works out. And the last one, I found the target numbers that multiply to equal negative 36 and add to equal 9 are 12 and negative 3. So I put it into the form n plus 12 and n plus negative 3. And when I FOILed it, I got n squared. And then I got 12n and negative 3n, which got me to 9n. And then I got negative 36. So that works for that one. So that is the basics of factoring these trinomials in that form, x squared plus bx plus c. Now, I do have a couple application problems here. Here's one. The area of a rectangle is given by the trinomial x squared minus 2x minus 35. What are the possible dimensions of the rectangle? Use factoring. So remember, when you're finding the area of a rectangle, so here we got a rectangle has two sides, and to find the area, you just find whatever the length times the width is, would be the area. So we're finding the two things that multiply together to equal this. So we're going to factor it to find the two things. So we want it to multiply to equal 35, negative 35, and add to equal negative 2. So they're both negatives in this case. So, well, here's a hint. If both A or B and C are negative, the larger target number will be negative and the smaller one will be positive. Okay? Because we want it to add to equal negative. But you have to have one positive and one negative to multiply to equal negative. So, let's find something that multiplies to equal negative 35 and adds to equal negative 2. So I can think of 7 and 5 will get to 35. So one of them would have to be a negative. The bigger one's going to be negative. So the target numbers are going to be negative 7 and 5. That gets you to negative 35, and it adds to equal negative 2. So put them in here, and I get x plus negative 7 and x plus 5. So that's what I'm going to say would be our two. So we'd have x plus 5. That would be right here. One dimension, and x plus negative 7 would be the other dimension. Oops. All right, so let's just double check. So if we do FOIL, we'd have first would be our first would be x squared, which is what we wanted there. Outsides would be 5x, inside would be negative 7x. That gets you to negative 2x, and then the last would be negative 35. So we did it correct. So I'd like you to try this one on your own then, very similar. We have a rectangle's area is x squared minus x minus 72. What are possible dimensions for the rectangle? Use factoring. Hint, hint. If there's no number in front of the x, put a 1 there. So go ahead, try it on your own, pause it, and then you can unpause it and see the work. Alright, so the two numbers that multiply to equal negative 72 and add to equal negative 1, I found were negative 9 times 8. So negative 9 times 8 gets you to negative 72, and when you add them together, you get negative 1. So when we factor it out, we get the two dimensions for this rectangle as x plus negative 9 and x plus 8. Alright, so then the other application that I have for you is one where you can factor a trinomial that has two variables, which is kind of interesting. So let's just read this through real quick. It says here, you can also factor some trinomials that have more than one variable. So if you look at the product p plus 9q times p plus 7q, you can FOIL that and you can get this trinomial where it's p squared plus 16pq plus 63q squared. So what we're going to do is go backwards. You're going to be given a trinomial that has two variables in it, and then we have to factor it to find what would be factored. So example here would be, what is the factored form of x squared plus 6x minus 55, or sorry, times plus 6xy minus 55y squared. So we want to find pairs of factors that multiply to equal negative 55, negative 55y squared, and add to equal 6y. Or just work on negative 55 and 6. So here's some ones that get to negative 55. There's not a lot of them. So we find that negative 5 and 11 get you to multiply to equal negative 55 and add to equal 6. So what we're going to do is we're going to add just the y to those. So really our factors are going to be, our target numbers are going to be, because each of these second terms have a y in them as well. So target numbers are going to be, we have 11y and negative 5y. And when you factor it, then you'd have, set up your thing, and you have your x minus 5y and x plus 11y. So the way it works is, if you FOIL it, it'll work out. We have x squared, we have minus 5xy, and then we have plus 11xy, which gets us to the plus 6xy. And then the last terms have minus 5y times plus 11y, which gets you negative 55y squared. So we're still finding target numbers, it's just we're adding that extra variable to our target numbers. So why don't you try this one on your own then. What is the factored form of m squared plus 6mn minus 27n squared? So last example, why don't you pause it and then check back in a second once you're done. Alright, so we're looking for target numbers that would get you multiplied to negative 27 or negative 27n squared, and then add to equal 6 or 6n, because the n is the extra variable there. So really, we're just trying to find numbers that multiply to equal -27 and equal 6, but then we add the n at the end. So those two numbers that I found are 9 and -3. So our target numbers really are 9n and -3n. And when you pop those into your binomials with the m, we get this as our factored form. And again, you can double check it by FOILing, and it will match up. It matches up to m squared plus 6mn minus 27n squared. So that was the second application where you have an extra variable in there. So just going back to what we were thinking about, what we've been talking about today, I just want you to think about what's the hardest part of factoring for you? What is the most challenging part of factoring? Or is there one? Because you're gonna get more practice with this, and this is gonna come in handy the next couple chapters. We'll even see this once you get to geometry. So there's factoring that's going to be involved in a lot of different things when it comes to trinomials like this. Okay, all right. So that brings us back to our learning target from the beginning, to factor trinomials of the form x squared plus bx plus c. And I think we've gotten a lot of practice in that and on that today. So hope you got something out of that. Hope you learned something. Hope you took some good notes. We'll see you next time.